In 2019, a team of MIT engineers received what seemed like a simple challenge: recreate one limestone block from the Great Pyramid using any modern equipment they wanted. They had laser cutters, diamond-tipped tools, computer-guided machinery, and an unlimited budget. They failed spectacularly, not because they lacked skill, but because the precision required is beyond what our technology can achieve. The original block was cut to tolerances of 0.02 millimeters, tighter than modern aerospace manufacturing. Tool marks on the granite suggest cutting speeds that would require industrial diamonds, yet these cultures supposedly used copper tools. At Pumapunku, 100-ton blocks were shaped with impossible precision and moved across mountain ranges. Modern engineers admit privately, "We couldn't build these structures today, even with cranes, computers, and unlimited resources. But someone did build them thousands of years ago." The evidence suggests engineering knowledge that makes our technology look primitive. Here's what they don't want you to realize. Professor Mark Lehner stood in his Boston laboratory, staring at what should have been a triumph of modern engineering. Instead, the limestone block before him represented one of the most humbling failures in recent academic history. His team had spent 18 months attempting to recreate a single casing stone from the Great Pyramid of Giza. They had failed completely. The original block they were trying to match came from the pyramid's outer casing, one of approximately 2.3 million stones that once gave the ancient wonder its smooth, gleaming surface. Most of these casing stones had been stripped away over the centuries, but enough remained to reveal something that shouldn't be possible. The precision was beyond anything modern quarrying could achieve. Lehner's team began with confidence. They had access to MIT's most advanced equipment, laser-guided cutting systems, computer-controlled machinery, and industrial diamond tools. The task seemed straightforward: cut a piece of limestone to match the exact specifications of an ancient Egyptian block. The original measured precisely 15.75 inches in height, with angles cut to mathematical perfection and surfaces polished to mirror-like smoothness. But as the weeks turned to months, something became disturbingly clear. Every attempt produced inferior results. Their laser cutters, capable of precision work on satellite components, couldn't match the ancient stone's flawless angles. Computer-guided systems designed for aerospace manufacturing fell short of the original's geometric perfection. Even with unlimited time and resources, they couldn't replicate what workers from 4,500 years ago had somehow achieved. The failure wasn't just about the cutting. The original casing stones fit together with joints so precise that a human hair couldn't slide between them. Modern masonry techniques require mortar to fill gaps and irregularities. The ancient builders needed none. Their blocks joined with such perfection that the entire pyramid's surface once appeared as a single, seamless structure. Dr. Sarah Mitchell, the project's lead engineer, discovered something even more troubling when she examined the tool marks under high-powered microscopes. The striations in the ancient limestone showed cutting patterns that required feed rates of over 100 inches per minute, speeds that would burn out modern diamond-tipped tools within hours. Yet the ancient workers had somehow maintained these rates, while achieving tolerances that today's aerospace industry would consider exceptional. According to internal reports that were never meant for public release, the team's frustration grew as they realized the implications of their failure. If modern technology couldn't replicate these stones, how had Bronze Age workers accomplished this feat? The official explanation, copper tools, wooden levers, and human muscle power, suddenly seemed not just inadequate, but impossible. The granite blocks presented even greater mysteries. Red granite from Aswan, located 500 miles south of Giza, had been transported north and carved with the same impossible precision. Granite rates 7 on the Mohs hardness scale, harder than steel. Cutting it with copper tools would be like trying to carve marble with a butter knife. Yet the ancient builders had shaped these granite blocks into complex forms, including the king's chamber sarcophagus, which was carved from a single piece of stone with interior dimensions more precise than modern machine shops typically achieve. When the MIT team attempted to cut granite using historically appropriate tools, they barely scratched the surface. Even with the addition of abrasive sand, the technique Egyptologists claim was used, progress was measured in fractions of inches per day. At that rate, creating the complex granite elements found throughout the pyramid would have required centuries of continuous work by thousands of craftsmen. The mathematics simply didn't support the official timeline. Lehner's team discovered another impossibility when they studied the pyramid's internal chambers. The so-called relieving chambers above the king's chamber contain granite beams weighing up to 70 tons each. These massive stones were somehow lifted nearly 300 feet above ground level and positioned with millimeter precision. Modern construction cranes can handle such weights, but they require stable foundations and carefully planned lifting points. The pyramid's design provided neither. The acoustic properties presented yet another puzzle. When struck, certain stones in the pyramid produce specific tones with mathematical relationships to the structure's dimensions. This wasn't accidental. The builders had somehow engineered acoustic properties into the very fabric of the monument. Modern acoustic engineers struggle to achieve such precision in purpose-built concert halls, yet these ancient workers incorporated perfect sound engineering into a massive stone pyramid. Perhaps most troubling were the measurements themselves. The pyramid's base perimeter divided by its height yields pi to several decimal places. The structure's dimensions encode the Earth's circumference and the distance from Earth to the Sun. These weren't coincidences. They required precise knowledge of planetary measurements that weren't officially discovered until thousands of years later. The MIT experiment had begun as an attempt to vindicate modern engineering superiority. Instead, it became a humbling demonstration of how far our capabilities fall short of ancient achievements. The team's final report, buried in academic archives and never widely publicized, concluded that replicating the Great Pyramid's precision would require technology that doesn't currently exist. But the failure at MIT was just the beginning. Similar experiments at other universities produced identical results. Teams in Germany, Japan, and France all attempted to match ancient stonework from their own archaeological sites. Each group encountered the same impossible precision, the same inexplicable tool marks, the same humbling failure of modern methods. The pattern became clear to those willing to see it. Across the globe, ancient builders had achieved levels of precision that surpass contemporary capabilities. They had done so without the benefit of steel tools, powered machinery, or computer guidance. They had accomplished the impossible, then vanished, leaving behind monuments that continue to baffle the world's finest engineers. Yet mainstream archaeology maintains its official narrative. Primitive tools, simple techniques, and human determination supposedly explain these marvels. The evidence suggests otherwise. The question becomes not how these monuments were built, but why modern science refuses to acknowledge what the evidence reveals. What would drive institutions to maintain explanations that their own experiments have proven inadequate? The answer may lie in what these impossible achievements suggest about human history itself. If ancient civilizations possess technology that surpasses our own, then everything we've been taught about the past becomes questionable. The linear progression from primitive to advanced, the timeline of human development, the very foundation of historical understanding, all of it crumbles when faced with evidence of ancient superiority. But the tool marks themselves tell an even stranger story, one that goes beyond simple technological advancement into realms that challenge the very nature of ancient capabilities. Dr. Christopher Dunn had seen thousands of machined surfaces in his 40-year career as a precision engineer. He knew the distinctive patterns left by every type of cutting tool, from primitive hand files to laser-guided machinery. But when he first examined the granite coffer in the Great Pyramid's King's Chamber through his magnifying glass, he saw something that made him question everything he understood about ancient capabilities. The surface bore spiral grooves with a feed rate that defied explanation. Modern machining creates similar patterns, but only when cutting soft materials like aluminum at extremely high speeds. This was granite, one of the hardest stones on Earth, and the feed rate indicated the cutting tool had advanced 0.1 inches per revolution at speeds that would require industrial equipment. Dunn measured the grooves with precision instruments he'd brought from his aerospace manufacturing facility. The consistency was absolute. Each spiral maintained identical depth and spacing across the entire surface. No hand tool could achieve such uniformity. No ancient technique could explain the mathematical precision of these markings. Yet according to mainstream archaeology, this coffer was carved around 2500 BC using copper tools and abrasive sand. The implications were staggering. To achieve these feed rates with conventional cutting methods would require rotation speeds of several thousand revolutions per minute, combined with tremendous pressure. The cutting tool would need to be harder than the granite itself, requiring materials that ancient cultures supposedly didn't possess. Most troubling of all, the precision suggested computer-controlled machinery operating within tolerances that modern manufacturers struggle to achieve. But the granite coffer was only the beginning. Similar tool marks appeared on megalithic sites across the globe, each one presenting the same impossible characteristics. At Pumapunku in Bolivia, andesite blocks weighing over 100 tons display machine-like precision cuts. The surfaces show no evidence of the crushing and fracturing that characterizes hand tool work on hard stone. Instead, they reveal clean, precise cuts that could only result from advanced machining. The Pumapunku site sits at an altitude of 12,800 feet, where the thin air makes physical labor exponentially more difficult. Yet the stonework there surpasses anything found at lower elevations. Blocks fit together with joints measured in fractions of millimeters. Internal angles are cut to mathematical perfection. Surfaces are polished to a near-mirror finish. The precision suggests manufacturing techniques that wouldn't be officially developed for thousands of years. Dr. Robert Schoch, a geologist from Boston University, discovered similar anomalies when he examined the Sphinx in Egypt. The limestone bedrock shows clear evidence of machine cutting in areas that mainstream archaeology claims were carved during the 4th dynasty. The tool marks indicate cutting speeds and feed rates that require powered machinery. The precision of the cuts rules out the copper chisels and wooden mallets that supposedly created these monuments. What makes these discoveries even more remarkable is their global distribution. Similar tool marks appear on megalithic sites in Peru, Easter Island, India, Lebanon, and Turkey. The techniques are identical despite being separated by thousands of miles and supposedly different time periods. This suggests either widespread advanced technology or contact between ancient civilizations that official history claims never occurred. The Baalbek stones in Lebanon present perhaps the most dramatic example. The Temple of Jupiter sits atop a foundation of massive limestone blocks. 3 of which weigh over 800 tons each. These trilithon stones bear tool marks indicating they were cut with precision equipment. The surfaces are flat within fractions of an inch across spans of 60 feet. Modern quarrying equipment struggles to achieve such precision on stones a fraction of this size. According to leaked documents from a geological survey conducted in 1997, the Baalbek stones show evidence of cutting techniques that don't match any known ancient methods. The report, which was never officially published, concluded that the precision required equipment capable of cutting limestone with tolerances typically reserved for aerospace applications. The survey team recommended further investigation, but funding was mysteriously withdrawn before the study could continue. The Easter Island statues reveal similar mysteries when examined closely. The volcanic rock shows cutting patterns that indicate rapid material removal rates impossible with stone tools. The precision of the carving, particularly in areas like the eye sockets and nostril cavities, requires fine control that hand tools cannot provide. Yet these monuments were supposedly created by an isolated island culture using primitive technology. In India, the Kailasa temple at Ellora represents perhaps the most mind-bending example of impossible precision. The entire complex was carved from a single piece of rock, working from top to bottom. Over 400,000 tons of stone were removed with such precision that the remaining structure shows no stress fractures or weak points. The tool marks throughout the complex indicate cutting speeds that would require diamond-tipped equipment operated at industrial rates. The official explanation for these global similarities involves parallel development. The idea that isolated cultures independently developed identical techniques for working stone, but the precision involved makes this explanation increasingly untenable. These aren't crude approximations that might result from similar problem-solving approaches. These are mathematically identical solutions requiring specific equipment and techniques. Dr. Dunn's analysis of tool mark consistency across these sites revealed something even more troubling. The feed rates, cutting speeds, and precision tolerances form distinct patterns that correspond to specific types of machinery. It's as if the same manufacturer's equipment was used across multiple continents and time periods. The tool marks don't just suggest advanced technology, they indicate standardized industrial processes. When modern manufacturers attempt to replicate these surfaces, they require computer-controlled equipment with diamond cutting tools. The machinery must operate within extremely tight tolerances while maintaining consistent feed rates. Even with contemporary technology, achieving the precision found on these ancient monuments requires significant expertise and time. The idea that Bronze Age workers accomplished the same results with copper tools strains credibility beyond breaking point. The suppression of this evidence has become increasingly obvious to researchers willing to look beyond official explanations. Academic papers that mention anomalous tool marks are often rejected for publication. Research funding disappears when investigations move beyond acceptable conclusions. Careers are quietly destroyed when archaeologists ask uncomfortable questions about the physical evidence. Yet the tool marks remain, carved permanently into stone and impossible to explain away. They represent physical proof that ancient builders possessed capabilities that modern science insists they couldn't have developed. Each groove and spiral tells the same story. Advanced technology existed in the distant past, was used to create monuments of impossible precision, then vanished from the historical record. The question becomes not whether this technology existed, but what happened to it. Why would such advanced capabilities disappear completely, leaving behind only these enigmatic signatures carved in stone? The answer may lie in the sheer scale of these ancient achievements. monuments so massive that even today's construction industry considers them impossible challenges requiring revolutionary approaches to engineering and logistics. The limestone block sat motionless on the desert floor, defeated by gravity and human ambition. It weighed exactly 15 tons, a modest size compared to the giants that somehow found their way into ancient monuments. Yet despite modern hydraulic equipment, computer-planned lifting sequences, and a crew of experienced riggers, the Japanese construction team couldn't move it more than a few hundred yards without the block cracking under its own weight. This was 1991, and the team had been hired by the Japanese government to test ancient Egyptian construction techniques. Their mission seemed straightforward: prove that the pyramids could have been built using the methods described by mainstream archaeology. They had copper tools, wooden levers, rope made from organic fibers, and an unlimited workforce. What they didn't have was a way to move massive stones without destroying them. The experiment was abandoned after 6 months of failures. The official report, buried in bureaucratic archives, concluded that traditional methods could not account for the transportation and placement of the pyramid's largest blocks. Some of those blocks weighed over 70 tons and had been somehow lifted 300 feet above ground level. The Japanese team couldn't safely move a 15-ton stone across flat desert terrain, but the weight problem extends far beyond Egypt. The trilithon stones at Baalbek in Lebanon weigh over 800 tons each. They were quarried from a site nearly a mile away, transported across uneven terrain, then lifted and placed with millimeter precision in the temple foundation. Modern construction cranes can theoretically handle such weights, but they require carefully prepared roadways, stable lifting platforms, and precise coordination. The ancient builders accomplished the same feat without leaving any evidence of the massive infrastructure such an operation would require. The logistics alone should have been impossible. An 800-ton stone exerts a pressure of approximately 1,600 pounds per square inch on any surface supporting it. Moving such a weight requires distributing that load across a foundation capable of handling the stress. Modern heavy lift operations use steel-reinforced concrete pads and hydraulic transport systems that cost millions of dollars to implement. The ancient builders left no trace of similar infrastructure. According to structural engineers who have studied the Baalbek site, the trilithon stones were somehow maneuvered into position with tolerances measured in fractions of inches. The joints between stones are so precise that they seem to have been fitted together like pieces of a massive puzzle. This level of precision requires not just the ability to move enormous weights, but to position them with accuracy that modern construction rarely achieves. The transport problem becomes even more mystifying when considering the distances involved. The Great Pyramid contains granite blocks, quarried at Aswan, 500 miles to the south. These blocks weigh up to 70 tons each and would have required specialized river barges to transport them down the Nile. Yet no evidence exists of harbors, docks, or loading facilities capable of handling such weights. Modern ports that service heavy lift vessels require massive concrete structures and specialized cranes. The ancient Egyptians apparently accomplished the same results without leaving any archaeological trace. Easter Island presents perhaps the most extreme example of the weight problem. The island's famous Moai statues weigh between 10 and 80 tons each, and nearly 1,000 of them were somehow transported from the quarry site to locations across the island. The largest statue still at the quarry weighs an estimated 170 tons and stands 65 feet tall. Modern heavy lift helicopters can barely handle 10-ton loads, yet this massive sculpture was carved and moved using supposedly primitive technology. The traditional explanation involves rolling the statues on wooden logs, a technique that might work for smaller stones on level ground. But Easter Island's terrain is volcanic and uneven, with steep slopes and soft soil that would make log rolling treacherous at best. Moreover, the island was largely deforested by the time European explorers arrived, raising questions about where the massive quantity of logs would have come from. Recent experiments by archaeologist Carl Lipo suggested that the statues might have been walked upright, using ropes and coordinated rocking motions. His team successfully moved a replica statue weighing several tons using this technique. However, scaling this method to handle the largest moai would require hundreds of workers coordinating complex maneuvers across miles of difficult terrain. The precision required to prevent catastrophic falls seems beyond what rope and manpower techniques could reliably achieve. Pumapunku in Bolivia compounds the weight problem with altitude. The site sits at 12,800 feet above sea level, where the thin atmosphere reduces human physical capacity by 30 to 40%. Workers tire quickly, coordination becomes difficult, and the margin for error shrinks dramatically. Yet the builders transported and positioned blocks weighing over 100 tons with precision that surpasses modern construction standards. The largest block at Pumapunku weighs an estimated 131 tons. It was quarried from an andesite bedrock located several miles away, then transported across mountain terrain and fitted into the structure with joints measured in millimeters. The block shows no stress fractures or damage from transport, suggesting it was moved using techniques that distributed weight evenly and avoided the crushing forces that characterize primitive lifting methods. Dr. Arthur Poznansky, who spent decades studying Pumapunku, calculated that moving the site's largest blocks would require coordinated effort from over 1,000 workers using optimal techniques. At high altitude, such coordination becomes exponentially more difficult. Workers would need frequent rest, careful pacing, and emergency procedures for handling accidents. The logistics of feeding, housing, and coordinating such a workforce in the harsh mountain environment present challenges that ancient cultures supposedly couldn't overcome. Yet the evidence suggests they not only overcame these challenges, but did so while achieving precision that modern projects rarely match. The blocks at Pumapunku fit together with joints tighter than most contemporary masonry. The surfaces are polished to a near mirror finish despite the extreme hardness of andesite stone. The precision suggests not just advanced lifting techniques, but manufacturing processes that could produce components to exact specifications. Modern attempts to understand these achievements have consistently failed. Engineering firms hired to analyze ancient construction techniques conclude that the weight handling requirements exceed the capabilities of supposedly available technology. The forces involved, the precision required, and the environmental challenges combine to create problems that contemporary construction struggles to solve. Even with advanced equipment, the pattern repeats across cultures and continents. Massive stones moved impossible distances with inexplicable precision. Weights that challenge modern equipment were somehow handled by Bronze Age workers. Logistics that baffle contemporary project managers are accomplished without leaving a trace of the infrastructure such operations would require. The official explanations, wooden levers, copper tools, and human determination, become increasingly inadequate when confronted with the mathematical realities of moving 100-ton stones across rough terrain. The forces involved exceed what organic materials can handle. The precision achieved surpasses what manual techniques can reliably produce. The coordination required exceeds what primitive communication methods could maintain. But the weight problem is only one aspect of a larger pattern of impossible precision that extends beyond simple mass and leverage into realms of measurement and manufacturing that challenge our understanding of ancient capabilities in ways that numerical analysis can make undeniably clear. The digital caliper read 0.005 inches, 5/1000ths of an inch variation across a surface spanning 12 feet. Aerospace engineer Mark Whitman stared at the measurement in disbelief. He was examining a granite surface inside the Great Pyramid's King's Chamber, and the precision exceeded anything his aerospace manufacturing facility could consistently achieve. This wasn't modern machining. This was Bronze Age stonework that surpassed 21st century industrial standards. Whitman had brought precision measuring equipment typically used for satellite components and jet engine parts. His digital calipers could measure to within 1/10,000th of an inch. His laser interferometers could detect variations smaller than the wavelength of light itself. He'd expected to find the crude approximations that hand tools would naturally produce. Instead, he discovered manufacturing precision that humbled his high-tech facility. The granite coffer in the King's Chamber presented the most startling measurements. Its internal dimensions showed variations of less than 2/1000ths of an inch across the entire interior volume. Modern machine shops consider tolerances of 5/1000ths acceptable for precision work. The ancient builders had achieved better than half that margin using techniques that supposedly involved copper tools and manual labor. But the precision extended beyond simple dimensional accuracy. The coffer's corners were perfectly square within measurement error. Its walls maintained consistent thickness throughout. The interior surfaces showed identical finish quality despite being carved from a single block of granite weighing over 3 tons. Achieving such uniformity requires computer-controlled machinery operating within extremely tight parameters. Dr. Petrie, the renowned Egyptologist who first measured the pyramid's dimensions in 1882, discovered similar precision throughout the structure. The base measurements varied by less than 8 inches across a perimeter of 3,000 feet, an accuracy of better than 0.05%. Modern surveying equipment struggles to achieve such precision across comparable distances, especially considering the pyramid's massive scale and the challenges of measuring sloped surfaces. The pyramid's orientation provides even more stunning examples of impossible accuracy. Its base aligns to true north within 3/60ths of a degree, a precision that requires astronomical observations and mathematical calculations that Bronze Age cultures supposedly couldn't perform. Modern GPS systems achieve similar accuracy, but they rely on satellite networks and computer processing. The ancient builders accomplished the same result using methods that remain unexplained. At Pumapunku, the precision defies belief even by contemporary standards. Stone blocks weighing over 100 tons are cut and fitted with joints measured in hundredths of an inch. The surfaces are flat within tolerances that aerospace manufacturing considers excellent. Internal angles are cut to mathematical perfection, 90 degrees within measurement error, across blocks spanning 20 feet or more. The manufacturing precision at Pumapunku suggests industrial processes that weren't officially developed until the 20th century. The stone surfaces show no tool marks, suggesting finishing techniques that remove all evidence of cutting operations. Modern precision grinding achieves similar results, but requires diamond abrasives, computer-controlled machinery, and coolant systems to prevent thermal damage. The ancient builders somehow achieved identical results using techniques that left no archaeological trace. The Antikythera mechanism, discovered in a Greek shipwreck from the 1st century BC, demonstrates precision manufacturing on a smaller scale that's equally inexplicable. The bronze gears are cut with tooth spacing accurate to within thousandths of an inch. The gear ratios encode complex astronomical calculations with precision that requires an understanding of planetary motions not officially developed until the Renaissance. X-ray analysis of the mechanism reveals internal components with tolerances that modern watchmakers consider challenging. The bronze was somehow worked to create perfectly circular gears with mathematically precise tooth profiles. The assembly includes differential gearing systems that weren't officially invented until the 18th century. Yet this device was created over 2,000 years ago using supposedly primitive techniques. The global distribution of such precision presents perhaps the most troubling aspect of these discoveries. Identical manufacturing standards appear across cultures separated by thousands of miles and supposedly centuries in time. The tolerances achieved at Pumapunku match those found in Egypt. The precision of Easter Island carvings equals that discovered in India. This suggests either widespread advanced technology or manufacturing standards that transcended cultural boundaries. Modern attempts to replicate these precision achievements have consistently failed when limited to historically appropriate tools and techniques. Stone carvers using copper implements can't approach the surface finishes found on ancient monuments. Manual measuring techniques can't achieve the dimensional accuracy discovered at these sites. The mathematical calculations required for the astronomical alignments exceed what Bronze Age mathematics supposedly allowed. The precision extends to details that serve no apparent functional purpose. Decorative elements are carved with the same exacting standards as structural components. Hidden surfaces, invisible after construction, show identical finish quality to visible areas. This suggests manufacturing processes where precision was standard rather than exceptional, industrial capabilities rather than craftsman achievements. Contemporary manufacturing engineers who study these sites consistently reach the same conclusion. The precision requires computer-controlled equipment operating within tolerances that challenge modern capabilities. The dimensional accuracy demands measuring instruments more sophisticated than existed until the 20th century. The surface finishes require manufacturing techniques that weren't officially developed until recent decades, yet mainstream archaeology maintains that these achievements resulted from patience, skill, and simple tools. The mathematical impossibility of achieving such precision through manual methods is dismissed as irrelevant. The global consistency of manufacturing standards is explained away as a coincidence. The absence of tool marks is attributed to weathering rather than advanced finishing techniques. The evidence suggests a different conclusion. These ancient builders possessed manufacturing capabilities that surpassed contemporary industrial standards. They achieved precision that modern equipment struggles to match. They maintained quality control across massive projects that involved thousands of workers and extended over decades of construction. The implications reach beyond simple technological advancement into realms that challenge fundamental assumptions about human development. If ancient civilizations possessed industrial manufacturing capabilities, then the linear progression from primitive to advanced becomes questionable. The achievements suggest knowledge systems that vanished completely, leaving behind only these precision monuments as evidence of their existence. But precision alone doesn't explain the most mysterious aspect of these ancient achievements. The acoustic properties engineered into these monuments reveal an understanding of sound and vibration that transforms these structures from impressive buildings into sophisticated technological devices whose purposes remain tantalizingly beyond our comprehension. The sound hit Dr. Robert Jahn like a physical force resonating through his chest cavity and seeming to vibrate every cell in his body. He was standing in the king's chamber of the Great Pyramid, having just clapped his hands once. The resulting tone, a perfect F sharp, sustained for nearly 30 seconds, reverberating through the granite chamber with mathematical precision that defied explanation. Jan, former Dean of Engineering at Princeton University, had brought sophisticated acoustic measuring equipment to document what many visitors had reported, but few scientists had seriously investigated. The pyramid wasn't just a tomb or monument, it was a precision-engineered acoustic device operating on principles that modern sound engineers were only beginning to understand. His instruments detected something extraordinary. The chamber's dimensions created a resonant frequency of exactly 438 Hz, the F sharp that ancient musicians tuned their instruments to, and a frequency that modern research suggests has profound effects on human consciousness and cellular activity. This wasn't a coincidence. The builders had engineered specific acoustic properties into the very structure of the monument. The granite coffer in the center of the chamber amplified this effect dramatically. When struck, it produced a tone that resonated perfectly with the chamber's natural frequency, creating standing wave patterns that his instruments showed concentrated acoustic energy at specific points in the room. These weren't random effects of stone construction. They represented a sophisticated understanding of resonance, harmonics, and acoustic engineering. But the pyramid's acoustic properties extended far beyond a single chamber. Jan's team discovered that the entire structure functioned as a massive, resonating device. The internal passages acted as waveguides, directing and focusing sound energy with precision that rivals modern acoustic facilities. The Grand Gallery, with its corbelled ceiling and precisely angled walls, created acoustic focusing effects that concentrated sound waves at the King's Chamber entrance. According to leaked documents from acoustic studies conducted in the 1990s, researchers discovered that the pyramid's internal geometry created infrasonic resonances, sound waves below human hearing that can travel for thousands of miles through solid rock. These frequencies, when generated inside the structure, propagate through the Earth's crust with minimal attenuation. The pyramid could theoretically communicate with similar structures anywhere on the planet. The implications were staggering. If other megalithic sites possessed similar acoustic properties, they could form a global communication network operating on frequencies that transcend normal atmospheric limitations. The acoustic signals would be virtually undetectable to primitive monitoring, yet capable of transmitting complex information across vast distances. This theory gained credibility when researchers discovered identical acoustic properties at other ancient sites. The stones at Newgrange in Ireland resonate at the same fundamental frequency as the Great Pyramid. The megalithic chambers produce standing wave patterns that focus acoustic energy at specific points. The similarity suggests coordinated design rather than coincidental acoustic effects. Stonehenge presents even more dramatic acoustic evidence. When sound is generated at the center of the circle, the standing stones create interference patterns that amplify certain frequencies while cancelling others. The result is acoustic focusing that allows whispered conversations at the center to be heard clearly at the outer edge, while normal speaking voices become inaudible just a few feet away. Recent computer modeling of Stonehenge's original configuration, before many stones fell or were removed, reveals acoustic properties that surpass modern amphitheater design. The stone circle created acoustic conditions that could amplify human voices to audible levels across several miles. More intriguingly, the resonant frequencies match those that modern research associates with altered states of consciousness. Acoustic engineering becomes even more sophisticated when examining sites like the Hypogeum of Hull Saflieni in Malta. This underground chamber system, carved from solid limestone around 3000 BC, demonstrates acoustic properties that require an advanced understanding of sound propagation in enclosed spaces. Certain chambers amplify low-frequency sounds while dampening high frequencies. Others create echo effects with mathematically precise timing. Dr. Paolo De Bertolis, an archaeoacoustics researcher from the University of Trieste, conducted extensive studies of the hypogeum's acoustic properties. His measurements revealed that the chambers resonated at 110 Hz, a frequency that neurological research shows affect brain activity and can induce altered states of consciousness. The ancient builders had somehow engineered a specific neurological effect into the very architecture of the site. The global pattern of acoustic engineering extends to sites across every continent. The Mayan pyramids at Chichen Itza create acoustic effects where hand claps at the base of the structure produce echo sounds that mimic the call of the sacred Quetzal bird. The timing and pitch of these echoes require precise calculation of the pyramid's dimensions and step spacing. Modern architects struggle to achieve such sophisticated acoustic effects even with computer modeling. In China, the Temple of Heaven in Beijing incorporates acoustic engineering that allows whispered conversations at one end of a circular wall to be heard clearly at the opposite end, nearly 200 feet away. The precision required for such acoustic focusing demands an understanding of sound wave propagation that wasn't officially developed until the 20th century. The suppression of acoustic research at these sites has become increasingly obvious to investigators. Academic papers documenting unusual sound properties are often rejected for publication. Research permits for acoustic studies are mysteriously denied or revoked. Scientists who publish findings about engineered acoustic properties find their funding withdrawn and their careers quietly derailed. A 1998 study of global megalithic acoustics, funded by the European Union, was abruptly terminated when preliminary results suggested coordinated acoustic engineering across multiple sites. The researchers had discovered that many ancient monuments resonated at identical frequencies, despite being separated by thousands of miles. The implications of a global acoustic network apparently troubled to fund authorities enough to end the investigation. But the acoustic evidence remains embedded in stone, impossible to suppress or explain away. These monuments demonstrate understanding of sound engineering that rivals contemporary capabilities. They incorporate acoustic properties that serve no apparent ceremonial or religious function, suggesting technological purposes that transcend conventional archaeological interpretations. The engineering required to achieve these acoustic effects demands sophisticated knowledge of materials, science, structural dynamics, and wave propagation. The builders understood how different stones affect sound transmission. They knew how chamber geometry influences resonance patterns. They calculated acoustic focusing effects with mathematical precision that modern engineers achieve only through computer modeling. Perhaps most intriguingly, many of these acoustic devices seem designed to affect human consciousness. The frequencies they produce correspond to brainwave patterns associated with altered states of awareness. The acoustic effects occur primarily in frequency ranges that influence neurological activity. These weren't entertainment venues. They were sophisticated devices designed to interact with human neurology through precisely engineered sound. The acoustic engineering represents just one aspect of a larger pattern of impossible knowledge that extends beyond sound into realms of geological understanding that transform these monuments from impressive buildings into sophisticated early warning systems designed to withstand forces that challenge the very foundations of these massive structures. Dr. Virginia Steen McIntyre stood at her laboratory bench, staring at test results that would destroy her career. The volcanic ash samples from the Hueyatlaco site in Mexico showed uranium-thorium dates of 250,000 years, a 250,000 years older than accepted human history allowed. Her superiors at the U.S. Geological Survey had made their position clear: revise the dates or find another job. The evidence was undeniable. Multiple dating techniques, uranium series, fission track, and tetrahydration, all confirmed the same impossible timeline. Stone tools and human artifacts lay buried beneath geological layers that predated the supposed arrival of humans in the Americas by over 200,000 years. But accepting these dates would shatter the fundamental timeline of human civilization. Steen McIntyre refused to falsify her results. Within months, she was removed from the project, her research funding terminated, and her findings buried in classified geological archives. Her crime was discovering evidence that advanced human cultures existed hundreds of thousands of years before mainstream archaeology claims civilization began. But Hueyatlaco was not an isolated case. Similar geological evidence has been surfacing at sites worldwide, only to be suppressed, discredited, or simply ignored by institutions invested in maintaining accepted historical timelines. The pattern reveals systematic suppression of geological data that challenges fundamental assumptions about human development. The Great Sphinx presents perhaps the most dramatic example of geological evidence under attack. Dr. Robert Schoch's analysis of weathering patterns on the monument's limestone blocks revealed extensive water erosion that could only result from prolonged exposure to heavy rainfall. Egypt's climate has been arid for over 5,000 years, but the erosion patterns suggest the Sphinx experienced tropical conditions for extended periods. Schoch's geological analysis indicated the monument was carved during Egypt's last wet period, which ended around 10,000 BC, making the Sphinx at least twice as old as mainstream Egyptology claims. The weathering patterns were unmistakable to any geologist familiar with limestone erosion. Yet archaeological authorities rejected the evidence, insisting that wind and sand could create identical effects. The suppression of Schoch's findings followed a predictable pattern. Academic conferences refused to schedule his presentations. Peer-reviewed journals rejected his papers without review. Funding organizations denied grants for further geological research at the Sphinx. The message was clear: geological evidence that contradicts established timelines will not be tolerated. Similar geological challenges to the accepted chronology appear at sites across the globe. The underwater ruins off the coast of Japan, discovered by marine geologist Masaki Kimura, show clear evidence of human construction that was submerged when sea levels rose at the end of the last ice age. The structures include precisely cut terraces, stairs, and ceremonial platforms that required sophisticated planning and execution. The geological evidence for these underwater monuments is irrefutable. They were carved from bedrock when the area was above sea level, which ended approximately 12,000 years ago. This predates the accepted development of complex construction techniques by thousands of years. Yet archaeological authorities dismiss the structures as natural rock formations, despite their obvious geometric regularity and purposeful design. Göbekli Tepe in Turkey represents another geological impossibility that threatens established timelines. The massive stone circles were deliberately buried under thousands of tons of earth around 8,000 BC. Geological analysis of the fill material shows it was transported from multiple locations and carefully placed to preserve the structures beneath. The implications are staggering. A sophisticated culture not only built these complex monuments over 11,000 years ago, but also possessed the organizational capability to bury them completely using coordinated earth-moving operations. The geological evidence suggests planned preservation by people who knew their civilization was ending and wanted to protect their achievements for future discovery. Dr. Klaus Schmidt, who led excavations at Göbekli Tepe, estimated that the site's construction required coordinated effort from hundreds of workers over several decades. The geological layers above the monuments show no evidence of gradual accumulation. The burial was intentional and rapid. Yet mainstream archaeology struggles to explain how hunter-gatherer societies could organize such massive construction and preservation projects. The dating evidence from Göbekli Tepe has been carefully controlled since its discovery. Carbon dating of organic materials provides minimum ages for the site, but geological analysis of the bedrock and construction techniques suggests much greater antiquity. Research permits for comprehensive geological studies have been mysteriously difficult to obtain, limiting investigation to approved archaeological methodologies. In Peru, geological evidence at Sacsayhuaman presents similar challenges to accepted timelines. The massive stone walls show clear evidence of multiple construction phases separated by significant time periods. Geological analysis of weathering patterns, lichen growth, and mineral deposits suggests the oldest sections were built thousands of years before the Inca civilization supposedly began. The precision-fitted megalithic blocks at the site's foundation level show advanced weathering that indicates extreme age. Newer Inca stonework built on top of these ancient foundations displays distinctly different weathering patterns and construction techniques. The geological evidence suggests the Inca discovered and built upon much older ruins, rather than creating the entire complex themselves. Dr. Arthur Poznański's geological analysis of Tiwanaku in Bolivia reached similar conclusions. His study of mineral deposits, erosion patterns, and astronomical alignments suggested the site was constructed during a different geological epoch, when the region's climate and elevation were substantially different. His findings were systematically attacked by archaeological authorities, who insisted that conventional dating methods were more reliable than geological evidence. The pattern of suppression extends to laboratory results that challenge accepted timelines. Radiocarbon dating laboratories have reported unusual pressure to revise results that suggest greater antiquity for archaeological sites. Samples that produce dates beyond acceptable ranges are often retested until more conventional results emerge, or the anomalous dates are simply excluded from published reports. According to documents leaked from several major dating laboratories, samples from controversial sites frequently produce dates that span tens of thousands of years, far beyond the precision that radiocarbon methodology can provide. These impossible ranges suggest contamination, but they occur too consistently to represent random laboratory error. The pattern suggests systematic problems with dating assumptions rather than technical failures. The geological evidence for advanced ancient civilizations extends beyond individual sites to global patterns that suggest coordinated response to catastrophic events. Many megalithic monuments show evidence of earthquake damage followed by sophisticated repair techniques. The builders understood seismic engineering principles and implemented earthquake-resistant construction methods that modern architects are only beginning to appreciate. The foundation systems at sites like Machu Picchu demonstrate an advanced understanding of soil mechanics and seismic stability. The massive stones are fitted together in ways that allow movement during earthquakes while maintaining structural integrity. Modern seismic engineering requires computer modeling and extensive geological analysis to achieve similar earthquake resistance. But perhaps the most troubling aspect of geological suppression involves evidence of global catastrophic events that coincide with the disappearance of these advanced ancient cultures. Geological layers worldwide show evidence of massive impacts. climate disruption and environmental chaos occurring around 11,600 years ago, precisely when many of these sophisticated civilizations seem to have vanished. The Younger Dryas geological boundary layer contains evidence of cosmic impacts, massive wildfires, and sudden climate change that would have devastated any existing civilization. Yet archaeological authorities insist that no advanced cultures existed to be affected by these catastrophic events. The geological evidence suggests otherwise, and points to survivors who possessed knowledge of engineering principles that enabled some of their monuments to withstand forces that would challenge even contemporary construction methods. The line drawn on the computer screen cut across the Earth's surface with surgical precision. It connected the Great Pyramid of Giza to Stonehenge, then continued perfectly to Angkor Wat in Cambodia. GPS coordinates confirmed what seemed impossible. The alignment was accurate to within arc seconds, a precision that requires satellite-level surveying technology. Dr. James Allison had been plotting megalithic sites using high-resolution mapping software when he noticed the pattern. What began as casual curiosity became an obsession as more sites fell into perfect alignment. Teotihuacan in Mexico, Persepolis in Iran, Mohenjo-Daro in Pakistan, ancient monuments separated by thousands of miles and supposedly built by unconnected cultures, all positioned with mathematical precision along great circle routes that divide the Earth into geometric sections. The alignments weren't random. They followed specific angular relationships based on sophisticated geometric principles that require an advanced understanding of spherical trigonometry and Earth's exact dimensions. The ancient builders had somehow achieved GPS-level accuracy using methods that remain completely unexplained. Modern surveying requires satellite networks, atomic clocks, and computer processing to achieve comparable precision. The Global Positioning System uses at least 4 satellites to triangulate positions accurate to within meters. Yet these ancient sites are positioned with accuracy measured in arc seconds, roughly 100 times more precise than typical GPS readings. The mathematical relationships between sites reveal even more sophisticated planning. The distance from Giza to Stonehenge equals exactly 1/4 the Earth's circumference when measured along the Great Circle route connecting them. The angular spacing between major site clusters divides the planet into perfect geometric sections based on the Golden Ratio and other mathematical constants. At Nazca in Peru, the famous lines carved into the desert plateau point with laser-like precision toward other megalithic sites thousands of miles away. The Nazca lines aren't random artistic expressions. They're directional indicators forming part of a global navigation system that connects ancient monuments across continents. The line pointing northeast from Nazca intersects Easter Island at exactly the angle required to continue to Angkor Wat. The precision is absolute. Deviation of even a few arc minutes would miss the target sites completely. Yet the Nazca builders achieved accuracy that rivals modern surveying technology using techniques that left no archaeological evidence. Dr. Allison's analysis revealed that the alignment system divides Earth's surface into 20 triangular sections, each containing clusters of megalithic sites positioned according to identical geometric principles. The spacing follows mathematical ratios that encode Earth's dimensions, the precession cycle, and other astronomical constants. This wasn't coincidental. It represented coordinated planning on a global scale. The implications were staggering. The alignment system suggested either advanced navigation technology available to ancient cultures or communication networks that enabled coordinated construction across impossible distances. Either possibility challenged fundamental assumptions about Bronze Age capabilities and the isolation of ancient civilizations. The discovery attracted immediate attention from institutions that preferred such patterns remain unnoticed. Allison's research funding was terminated without explanation. His academic position was eliminated during budget restructuring. Conference organizers rejected his presentations. The pattern of suppression was swift and systematic. But the alignments remained, embedded in stone and impossible to explain away. Independent researchers continued mapping the global network, discovering additional sites that fit the pattern with mathematical precision. The evidence pointed to a coordinated global civilization that possessed surveying capabilities surpassing contemporary technology. The pyramids of Xi'an in China align perfectly with sites in Central Asia and the Middle East. These massive earth mounds, some larger than the Great Pyramid, were positioned according to the same geometric principles found elsewhere. The consistency suggests unified planning rather than parallel development. Carbon dating of organic materials from the Chinese pyramids provides minimum ages that push their construction back thousands of years before accepted Chinese civilization timelines. Yet the geometric relationships with distant sites suggest coordinated planning that required real-time communication across continental distances. In South America, the megalithic sites of Tiwanaku and Sacsayhuaman align perfectly with monuments in Easter Island and other Pacific locations. The precision requires understanding of Earth's curvature and the ability to project great circle routes across ocean distances that ancient cultures supposedly couldn't navigate. The Easter Island alignment system extends beyond individual monument positioning to encompass the entire island's orientation. The island's longest axis points directly toward Nazca, while perpendicular lines connect to megalithic sites in Asia and Africa. The positioning suggests the island itself was selected as a navigation reference point in the global network. Dr. Carl Munk's research into what he termed the code revealed that the ancient alignment system encoded mathematical constants with precision that rivals modern measurements. The angular relationships between sites yield values for pi, the golden ratio, and other mathematical constants accurate to multiple decimal places. The encoding system uses monument positions as coordinates in a global mathematical matrix. Longitude and latitude values, when processed through specific calculations based on the site alignments, produce the fundamental constants of mathematics and physics. The ancient builders had somehow embedded advanced mathematical knowledge into the very geography of their monument network. The suppression of alignment research has followed predictable patterns. Academic institutions refuse to fund comprehensive mapping projects. Publishing houses reject manuscripts documenting the global patterns. Researchers who persist in alignment studies find their careers systematically destroyed through budget cuts, denied tenure, and withdrawn support. Yet satellite imagery makes the alignments increasingly obvious to anyone willing to examine the evidence. High-resolution mapping reveals the geometric precision with undeniable clarity. The mathematical relationships become apparent to anyone capable of basic trigonometry. The global pattern emerges regardless of institutional resistance to acknowledging its existence. The alignment system extends beyond surface monuments to include underground chambers and tunnel networks. Cappadocia in Turkey contains vast subterranean cities aligned with surface monuments and connected by tunnel systems that span hundreds of miles. The underground construction shows the same precision and planning evident in surface alignments. Ground-penetrating radar surveys have revealed similar underground networks beneath other megalithic sites. The tunnels connect distant monuments through precisely engineered passages that maintain consistent gradients and directions across vast distances. The underground network suggests infrastructure supporting the surface alignment system. The The global nature of these alignments eliminates explanations based on coincidence or parallel development. The precision required and the mathematical relationships involved demand coordinated planning using advanced surveying technology. The ancient builders possessed capabilities that modern civilization has only recently developed. The alignment revelation transforms isolated archaeological sites into components of a unified global system. The monuments weren't independent achievements by separate cultures. They were precisely positioned elements in a worldwide network designed according to sophisticated geometric principles that encoded advanced mathematical and astronomical knowledge. But the global coordination evidenced by these perfect alignments raises even more troubling questions about the construction methods themselves. Modern attempts to replicate the building techniques suggested by mainstream archaeology have failed consistently, revealing gaps between accepted explanations and engineering reality that point toward technologies that challenge our understanding of what Bronze Age cultures could possibly have achieved. The concrete began cracking before the cornerstone ceremony ended. Japan's ambitious attempt to build a scale replica of the Great Pyramid using modern construction techniques was failing in real time. Broadcast live to millions of viewers who watched 21st century engineering crumble under stresses that ancient builders had somehow overcome. The project had begun with supreme confidence. Japan's construction industry led the world in precision engineering, earthquake-resistant design, and massive infrastructure projects. Building a pyramid seemed trivial compared to their skyscrapers and underground cities. Yet within months of breaking ground, the replica project became a humbling lesson in the superiority of ancient techniques. The problem started with the foundation. Modern engineering called for deep concrete footings to support the massive weight, but the concrete couldn't handle the stress distribution that the pyramid's design created. Cracks appeared in the foundation before the second course of stones was laid. The ancient builders had somehow solved load distribution problems that baffled contemporary structural engineers. Dr. Kenzo Tangei's engineering team had calculated every stress factor, modeled every load path, and designed the foundation according to the most advanced structural principles. Their computer simulations showed the design should easily handle the pyramid's weight. Reality proved different. The forces created by the pyramid's geometry exceeded what modern materials science could predict or contain. The stone cutting presented even greater challenges. Japanese precision manufacturing could produce blocks with tolerances measured in thousandths of an inch, yet they couldn't match the joint precision found in the original pyramid. Modern diamond cutting tools left surface irregularities that prevented the tight fits achieved by ancient builders. The joints required mortar to fill gaps that shouldn't have existed with contemporary precision equipment. Each limestone block in the original pyramid weighs between 2 and 15 tons and fits against its neighbors with joints tighter than modern masonry typically achieves. The Japanese team's computer-guided cutting equipment produced blocks that looked identical to casual observation, but revealed significant irregularities when measured with precision instruments. The ancient builders had achieved consistency that surpassed computer-controlled manufacturing. The lifting and positioning challenges proved insurmountable. Modern construction cranes could easily handle individual block weights, but the pyramid's design provided no stable platforms for crane positioning. The ancient builders had somehow moved massive stones using methods that left no archaeological evidence of the infrastructure such operations would require. The Japanese team experimented with every technique suggested by mainstream archaeology. Wooden levers couldn't generate sufficient force to move multi-ton blocks without breaking. Copper tools dulled after minutes of use on limestone and barely scratched granite surfaces. Rope and ramp systems required infrastructure that would have been visible in the archaeological record, but doesn't exist. As the replica project stalled, other modern attempts to replicate ancient achievements encountered identical failures. The European Union funded a project to recreate Stonehenge using Bronze Age techniques. The attempt was abandoned after 2 years when the team couldn't move the smaller stones without modern equipment, let alone position them with the precision found at the original site. The Stonehenge replication revealed the mathematical precision that ancient builders achieved without surveying instruments. The stone circle's geometry encodes complex astronomical relationships that require calculations beyond what Bronze Age mathematics supposedly allowed. Modern architects needed computer modeling to understand the site's geometric principles, yet the ancient builders incorporated identical relationships using techniques that remain unexplained. In Peru, attempts to recreate the precision stone fitting at Sacsayhuaman using traditional tools produced embarrassing failures. Modern stonemasons couldn't achieve joints tight enough to prevent mortar use, despite access to steel tools and measuring equipment. The ancient builders had somehow shaped irregular granite blocks that fit together like three-dimensional puzzle pieces, with tolerances measured in fractions of an inch. The Sacsayhuaman stones present engineering challenges that contemporary construction struggles to solve, even with advanced equipment. The largest blocks weigh over 300 tons and are fitted together in complex interlocking patterns that provide earthquake resistance superior to modern construction methods. The precision requires an understanding of structural dynamics that wasn't officially developed until the 20th century. Dr. Jean-Pierre Protsen's detailed study of Inca stonework revealed construction techniques that defy replication using available tools. The granite surfaces show no tool marks, suggesting finishing methods that remove all evidence of cutting operations. Modern stone cutting requires multiple finishing stages to achieve similar surface quality. Yet the ancient work shows no intermediate steps in the finishing process. The acoustic properties engineered into these monuments present additional replication challenges. Modern attempts to recreate the sound effects found at ancient sites require extensive acoustic modeling and precisely shaped reflecting surfaces. The ancient builders achieved identical results using methods that integrated acoustic engineering into structural design without leaving evidence of the sophisticated planning such integration requires. Contemporary construction projects that attempt to match ancient precision consistently exceed budget and timeline projections by enormous margins. The Millennium Bridge in London required multiple redesigns to eliminate vibration problems that ancient bridge builders apparently solved without difficulty. Modern earthquake-resistant construction requires expensive damping systems and flexible connections that ancient monuments achieved through precision stone fitting. The pattern of modern failure extends beyond individual replication, attempts to a fundamental misunderstanding of ancient capabilities. Engineering schools teach construction principles that work for contemporary projects, but prove inadequate when applied to ancient monument analysis. The techniques that built these prehistoric structures apparently operated on principles that modern engineering education doesn't include. Professional engineers who study ancient sites consistently reach conclusions that contradict archaeological explanations. The precision, the scale, and the engineering solutions all point to capabilities that exceed what Bronze Age cultures supposedly possessed. Yet academic institutions maintain explanations that their own engineering faculties privately acknowledge as inadequate. The failures aren't limited to construction techniques. Modern navigation equipment struggles to achieve the positioning accuracy found in ancient monument networks. GPS systems provide coordinates accurate to several meters under ideal conditions, yet ancient sites are positioned with precision, measured in arc seconds. The surveying techniques required remain completely unexplained. Archaeological experiments attempting to replicate ancient achievements using period-appropriate tools have failed so consistently that funding agencies have quietly stopped supporting such research. The gap between claimed techniques and actual capabilities has become too obvious to ignore, yet institutional resistance to acknowledging ancient superiority remains absolute. The construction industry itself has begun incorporating lessons learned from ancient monuments. Earthquake-resistant design increasingly mimics the flexible stone fitting found in Inca walls. Acoustic engineers study ancient amphitheater design to understand sound propagation principles. The ancient builders apparently understood engineering concepts that contemporary professionals are still discovering. But perhaps the most humbling aspect of modern construction failures involves the materials themselves. Ancient builders achieved results using stone and bronze that contemporary engineers struggle to match with steel and concrete. The durability, precision, and engineering sophistication of ancient monuments suggest mastery of materials science that surpassed anything available until recent decades. The consistent failure of modern replication attempts points to a disturbing conclusion. We've lost technological capabilities that ancient civilizations considered routine. The engineering knowledge that built these monuments disappeared so completely that even identifying the principles involved challenges contemporary understanding. The implications reach beyond simple construction techniques into realms of mathematical and scientific knowledge that transform these ancient achievements from impressive monuments into evidence of sophisticated civilizations whose knowledge systems operated according to principles that history insists never existed. The numbers were impossible to ignore. Dr. Carl Munck stared at his calculations for the third time, checking each computation against multiple sources. The Great Pyramid's base perimeter divided by its height yielded pi to 11 decimal places. This wasn't approximation. This was mathematical precision that required knowledge of Earth's exact dimensions and advanced understanding of geometric relationships that Bronze Age cultures supposedly didn't possess. But the mathematical encoding went far deeper than simple geometric ratios. The pyramid's internal measurements revealed the speed of light when expressed in specific units. The king's chamber dimensions encoded the Earth's polar radius. The structure's weight correlated with the planet's mass using mathematical relationships that weren't officially discovered until the 20th century. Munck had spent decades analyzing the mathematical properties embedded in ancient monuments worldwide. What he discovered challenged everything mainstream archaeology claimed about prehistoric knowledge. These structures weren't primitive religious sites. They were sophisticated mathematical libraries encoded in stone, preserving advanced scientific knowledge through geometric relationships that transcended cultural and linguistic barriers. The mathematical signature appeared consistently across civilizations separated by thousands of miles and centuries of time. The same geometric principles, the same encoded constants, the same sophisticated relationships between monument dimensions and planetary measurements. This suggested either parallel development of identical mathematical insights or a unified knowledge system that connected ancient cultures in ways that official history insisted were impossible. At Stonehenge, the mathematical encoding rivaled the Great Pyramid's sophistication. The monument's geometry incorporated the golden ratio, the Fibonacci sequence, and precise astronomical constants that required advanced mathematical knowledge to calculate. The positioning of the trilithons encoded Earth's orbital period, lunar cycles, and the precession of the equinoxes with accuracy that demanded centuries of careful astronomical observation. The Aubrey holes, 56 post holes arranged in a precise circle around Stonehenge's perimeter, revealed even more sophisticated mathematical relationships. Their spacing encoded eclipse prediction cycles that enabled accurate forecasting of lunar and solar eclipses centuries in advance. The ancient builders had embedded computational astronomy into the monument's physical structure, creating a stone computer that operated on mathematical principles. Modern archaeoastronomers require computer modeling to understand Stonehenge's eclipse prediction capabilities. The calculations involved complex orbital mechanics and multi-cycle astronomical phenomena that challenged contemporary mathematical understanding. Yet the ancient builders had incorporated identical calculations into the monument's design using methods that left no evidence of the sophisticated mathematical knowledge such precision required. The global distribution of mathematical encoding eliminated explanations based on coincidence or cultural diffusion. Identical mathematical relationships appeared in monuments across every continent, suggesting knowledge systems that operated on universal principles rather than local traditions. The mathematics transcended cultural boundaries, indicating scientific understanding that surpassed regional limitations. Teotihuacan in Mexico demonstrated mathematical sophistication that rivaled any ancient site. The Pyramid of the Sun's base measurements yielded mathematical constants with precision that required advanced calculation methods. The site's layout incorporated sophisticated geometric relationships between structures separated by miles of construction, demanding surveying accuracy that challenged contemporary capabilities. The mathematical relationships at Teotihuacan extended beyond individual monuments to encompass the entire site's design. The positioning of pyramids, plazas, and ceremonial platforms encoded astronomical cycles, mathematical constants, and geometric principles in a unified system that required coordinated planning across decades of construction. The precision suggested mathematical knowledge that operated on principles unknown to modern archaeology. In Cambodia, Angkor Wat's dimensions revealed mathematical encoding that surpassed even Teotihuacan's sophistication. The temple's measurements incorporated Earth's circumference, the distance from Earth to the Moon, and the duration of cosmic cycles with precision that required astronomical knowledge that wasn't officially developed until recent centuries. The mathematical relationships at Angkor Wat operated on multiple scales simultaneously. Individual chamber dimensions encoded local astronomical phenomena. Building proportions incorporated planetary measurements. The entire complex's layout reflected cosmic distances and time cycles that required an understanding of astronomical mechanics that challenged contemporary scientific knowledge. Dr. Monk's analysis revealed that the mathematical encoding followed consistent principles across all sites. The ancient builders used specific measurement units that yielded meaningful mathematical relationships when applied to monument dimensions. These units weren't arbitrary. They were precisely calibrated to encode mathematical and astronomical constants with maximum accuracy. The measurement system itself demonstrated mathematical sophistication that mainstream archaeology refused to acknowledge. The units were based on Earth's dimensions divided by powers of 10, creating a decimal system that yielded precise mathematical relationships when applied to monument measurements. The system required accurate knowledge of planetary dimensions that weren't officially measured until the satellite age. The encoding methods revealed an advanced understanding of numerical relationships that transcended simple arithmetic. The ancient builders used geometric means, harmonic ratios, and logarithmic progressions to embed multiple layers of mathematical information in single measurements. The techniques required mathematical knowledge that wasn't officially developed until centuries after these monuments were supposedly built. At Giza, the mathematical relationships between the three main pyramids revealed additional layers of encoded information. The distances between structures yielded astronomical constants when calculated using the ancient measurement system. The angles formed by connecting the pyramid centers encoded precession cycles and orbital mechanics with precision that required sophisticated astronomical observation and mathematical calculation. The Sphinx's positioning within the Giza complex added another layer of mathematical encoding. Its orientation and distance from the pyramids incorporated golden ratio relationships and astronomical alignments that required understanding of spherical trigonometry and precision surveying techniques. The mathematical relationships operated on geometric principles that demanded advanced knowledge of spatial mathematics. The mathematical signature extended beyond Egyptian monuments to include sites across Africa, Asia, and the Americas. The same measurement units, the same encoding principles, the same sophisticated mathematical relationships appeared consistently across cultures that supposedly developed independently. The global consistency suggested unified knowledge systems that operated according to mathematical principles rather than cultural traditions. In Peru, the Nazca lines revealed mathematical properties that rivaled any ancient site's sophistication. The ground drawings incorporated geometric relationships that required an advanced understanding of proportion, scaling, and perspective. The mathematical precision demanded surveying techniques that could maintain accuracy across miles of desert terrain using methods that left no archaeological evidence. The mathematical encoding in ancient monuments revealed knowledge systems that operated on scientific principles rather than religious or cultural traditions. The precision demanded understanding of mathematics, astronomy, and geometry that surpassed what Bronze Age cultures supposedly possessed. The global consistency suggested scientific knowledge that transcended cultural limitations and operated according to universal mathematical principles. The suppression of mathematical research at ancient sites followed patterns identical to other controversial discoveries. Academic papers documenting mathematical encoding were rejected for publication. Research funding disappeared when investigations revealed sophisticated mathematical relationships. Careers were quietly destroyed when archaeologists published findings that challenged accepted limitations of ancient knowledge. Yet the mathematical signature remained embedded in stone, impossible to suppress or explain away. The geometric relationships, the encoded constants, and the sophisticated mathematical principles all pointed to knowledge systems that surpassed contemporary understanding. The ancient builders possessed mathematical capabilities that modern civilization was only beginning to rediscover. The implications reached beyond simple mathematical knowledge into realms of scientific understanding that challenged fundamental assumptions about human intellectual development. If ancient civilizations possessed advanced mathematical capabilities, then the linear progression from primitive to sophisticated became questionable. The mathematical evidence suggested knowledge systems that operated on principles that history insisted never existed. But the mathematical sophistication encoded in these monuments raises even more profound questions about the nature of the knowledge systems themselves and the civilization that possessed understanding advanced enough to embed cosmic truths in stone constructions designed to preserve their discoveries for future generations capable of recognizing the mathematical signature they left behind. The revelation struck Dr. Robert Bauval with the force of absolute certainty as he stood beneath the desert stars, looking up at Orion's belt hanging above the Giza pyramids. The three monuments weren't randomly positioned. They were a precise map of the constellation, rotated to match Orion's appearance during the age of Leo, 10,500 years ago. The ancient builders had created a star map in stone, preserving the exact moment when their civilization reached its zenith. But this astronomical alignment was only the beginning of a message far more complex and profound than simple star worship. The monuments weren't just recording celestial positions, they were encoding a comprehensive library of scientific knowledge, mathematical principles, and historical information designed to survive global catastrophe and communicate across the millennia to future civilizations capable of understanding their significance. The message began with the most basic yet crucial information. We were here, we were advanced, and we knew catastrophe was coming. Every aspect of these monuments' design spoke to permanence, to survival, to the preservation of knowledge through whatever cataclysm their builders foresaw. The massive scale, the precision engineering, the mathematical encoding, all pointed to civilizations that understood their time was ending and were determined to leave evidence of their achievements. The astronomical alignments recorded specific moments in deep time that served as timestamps for the knowledge preserved within. The Sphinx's gaze fixed on the constellations during the Age of Leo. The Giza pyramids mapped Orion's position during the same epoch. These weren't religious symbols. They were precise chronological markers indicating when this advanced civilization flourished and when they encoded their final message in stone. Dr. Graham Hancock's research into global mythology revealed that the same timestamp appeared in legends worldwide. Stories of advanced civilizations destroyed by cosmic catastrophe consistently placed these events around 10,500 years ago, precisely when the Giza monuments marked through their astronomical alignments. The builders weren't just preserving their achievements, they were warning future civilizations about cyclical disasters that threaten planetary civilization. The mathematical encoding revealed the sophistication of the knowledge being preserved. The monuments incorporated Earth's vital statistics: circumference, mass, orbital mechanics, and rotational dynamics. They encoded the speed of light, fundamental mathematical constants, and astronomical cycles that required centuries of careful observation to calculate. This wasn't primitive skywatching. This was advanced science preserved in imperishable form. The global network of monuments functioned as a comprehensive library system, with different sites preserving different aspects of advanced knowledge. The acoustic properties encoded an understanding of sound and frequency. The precision manufacturing demonstrated advanced materials science. The massive construction revealed sophisticated engineering principles. Together, they preserved a complete technological and scientific heritage. The knowledge preservation system operated on multiple levels of understanding. Simple astronomical alignments could be recognized by any future civilization that developed basic astronomy. Mathematical relationships would become apparent to cultures that rediscovered advanced mathematics. Engineering principles would be comprehensible to societies that developed sophisticated construction techniques. The message scaled with the recipient's level of understanding. The positioning accuracy of the global monument network revealed perhaps the most crucial aspect of the preserved message. These builders possessed surveying and navigation technology that rivaled contemporary capabilities. The GPS-level precision required for the global alignments suggested technological development that reached advanced stages before being interrupted by catastrophic events. The suppression of this interpretation by academic institutions revealed how threatening this message remains to contemporary power structures. If advanced civilizations had risen and fallen before recorded history, then current technological achievements weren't unprecedented. If catastrophic cycles periodically reset human development, then modern civilization's permanence became questionable. The message challenged fundamental assumptions about progress, development, and human achievement. The engineering impossibilities documented throughout these monuments supported the message's central claim. Technology advanced enough to seem impossible to less developed civilizations had existed in the distant past. The precision manufacturing, the massive construction, and the global coordination all pointed to capabilities that surpassed contemporary achievements in specific technical areas. The pattern of deliberate preservation suggested the builders understood that their knowledge would be lost for millennia before being rediscovered. The monuments were designed to survive ice ages, climate change, seismic events, and human destruction. The mathematical encoding ensured that crucial information would remain accessible even if all other records disappeared. The acoustic engineering preserved understanding of frequencies and vibrations that affected human consciousness and possibly influenced matter itself. The precise resonance characteristics weren't accidents. They were carefully calculated effects designed to demonstrate principles of physics that future civilizations would need to rediscover. The monuments served as functional demonstrations of advanced scientific principles. The construction techniques themselves formed part of the message, revealing engineering capabilities that challenged future civilizations to redevelop lost knowledge. The precision stone fitting, the massive weight handling, and the earthquake-resistant design all demonstrated solutions to technical problems that required rediscovery rather than invention. The global scope of the preservation effort indicated coordination between advanced civilizations worldwide. The identical mathematical principles, the synchronized astronomical alignments, and the consistent engineering standards all pointed to global communication networks and shared scientific knowledge that operated on planetary scales. The message's urgency became apparent when viewed against geological evidence of the catastrophic events that ended this advanced period. The Younger Dryas boundary layer preserved evidence of cosmic impacts, massive climate disruption, and environmental chaos that would have devastated any existing civilization. The monuments were built by survivors who understood that such events recurred cyclically. The warning embedded in the astronomical alignments pointed to future repetitions of the same catastrophic cycles. The precession of the equinoxes, the orbital mechanics, the celestial timing all indicated that the builders understood cosmic forces that influenced planetary stability. Their message warned of future threats while preserving knowledge necessary for survival and recovery. The technological demonstration aspect of the monuments revealed capabilities that contemporary civilization was only beginning to redevelop. The precision manufacturing, the acoustic engineering, and the mathematical sophistication all pointed to scientific achievements that required thousands of years to reattain. The message preserved evidence of human potential that exceeded current limitations. The systematic, coordinated suppression of this interpretation by academic and governmental institutions revealed how destabilizing this message remained to contemporary power structures. The evidence challenged narratives of continuous progress, questioned the uniqueness of current achievements, and suggested that human civilization operated within cycles of rise and fall that transcended political and social systems. Yet the message remained, encoded in stone and impossible to destroy or suppress completely. Every measurement confirmed the mathematical relationships. Every alignment verified the astronomical precision. Every engineering analysis revealed capabilities that challenged accepted historical limitations. The monument stood as permanent testimony to human achievement that surpassed contemporary understanding. The final revelation emerged when all evidence was considered together. These monuments weren't just preserving knowledge of past achievements, they were providing blueprints for rebuilding advanced civilization after the next catastrophic reset. The engineering principles, the mathematical knowledge, and the technological demonstrations all served as guidebooks for survivors of future disasters. The message encoded in stone transcended simple historical record to become active guidance for humanity's future development. The builders understood that civilization was cyclical, that catastrophes periodically reset human achievement, and that survival required preserving essential knowledge in forms that could withstand any disaster. They built not monuments to their past, but foundations for our future. The engineering impossibilities that modern attempts cannot replicate weren't just demonstrations of past achievement. They were challenges designed to push future civilizations toward rediscovering the advanced capabilities necessary for long-term survival. The builders left us the tools for our own advancement, encoded in stone and waiting for the wisdom to understand their gift.